small is not the same as zero, and indeed, Canadian astronomer Paul Weird has now come to the conclusion that the probability of impact for the asteroid Apophis is higher than previously thought. Basically, the 350-meter-wide projectile will pass close to Earth in April 2029, well, provided that its trajectory remains unchanged until then, of course. But that is precisely the crux of the matter. According to Weird, even a collision with a small object could be enough to send Apophis off on an unfortunate path. The fact that we cannot even weigh up the real danger at the moment makes the situation no less tricky. Unfortunately, the asteroid will not return into our field of vision until 2027. If you like, Apophis holds two records. On the one hand, the asteroid reached the highest value of all time on the Turing risk scale in 2004. On the other hand, as a supposed killer asteroid, it also triggered record-breaking media hysteria. Discovered in June 2004 by Roy Tucker, David G. Tholen, and Fabrizio Bernard, the space rock quickly attracted the unwelcome attention of being on a collision course with Earth on April 13, 2029, a Friday the 13th, no less. The corresponding impact probability was estimated at 1 in 37, or 2.7%. And this did not only apply to April 2029 but also to the years 2036 and 2068. Fortunately, however, the media and astronomical situation has long since eased again, and as a result of detailed follow-up observations, it's now even considered impossible that Apophis will come into close contact with our earthly home in 4 years. Well, unless something happens in the coming months and years that literally throws the asteroid off its course. But more on that later. Because basically, it's certain that even in the worst-case scenario, our Earth would have a lucky escape. In other words, even if Apophis were to collide with Earth, the impact would not unleash a global catastrophe like the asteroid impact that ushered in the end of the dinosaurs 66 million years ago. The object, with its diameter of 350 meters, is simply too small for that. Although, conversely, this does not mean that the consequences of a direct hit would not be fatal. According to the experts, the impact crater alone would devastate an area of several kilometers in diameter, and the force of the impact would be enough to destroy an area the size of Central Europe. Expressed in figures, this means nothing less than that Apophis would release an energy of 900 million tons of TNT, which, in turn, is 60,000 times greater than the destructive power inherent in the atomic bomb dropped on Hiroshima. But to affect the entire Earth's surface, it would need another 100 times more energy. The exact consequences of a hypothetical asteroid impact would depend primarily on where the object hits the Earth. If the asteroid were to crash into the sea rather than the mainland, it could bury the nearby coasts under a monster tsunami over 100 meters high. But fortunately, we can now banish such depressing thoughts from our minds because, as I said, past trajectory observations have shown that Apophis will pass very close to our home planet. By the way, the term hair's breadth in this astronomical context means a distance of over 30,000 kilometers, so that the 2029 asteroid will still pass below the geostationary orbit. And yet, at the end of the day, the all-clear given by the researchers still has a small caveat: we will only get the green light on asteroids if nothing unforeseen happens between now and then. In other words, Apophis will only miss Earth if it maintains its current trajectory. And strictly speaking, this is no longer the case. A few years ago, scientists discovered that the radiation pressure of the Sun shifts the asteroid's orbit by around 170 meters annually. And although this deviation is not enough to direct Apophis towards Earth in 2029, it could still lead to an impact on a later passage. And the bottom line is that this is by no means the only risk. Paul Weird, an expert in orbit calculations at the University of Western Ontario, warns that even the best current projections cannot rule out the possibility that Apophis will be hit by a smaller object during its journey through space. But how big would the object have to be to knock a 350-meter chunk off course? Well, probably significantly smaller than you think. After all, in the fall of 2022, NASA impressively demonstrated how the orbit of a larger object can be successfully manipulated by the targeted impact of a significantly smaller one. As part of the DART mission, the autonomous spacecraft had acted as a flying battering ram, crashing into the surface of the 165-meter-wide asteroid moon, Dimorphos. But while this cosmic diversionary maneuver was nothing more than a test run under real conditions, such a hit could have much more serious consequences in the case of Apophis. Weird states that even a collision with a small asteroid, such as those that regularly hit the Earth, could transfer enough momentum to deflect Apophis from its orbit. In view of this, the experts are well advised to keep a close eye on the spacecraft. And they would probably do so even if they could still see it at the moment. In reality, however, Apophis disappeared from our field of vision as early as 2021. And since it's currently moving close to the Sun, it appears invisible even to the most powerful telescopes of our time. This will not change until 2027. But what happens in the meantime, and whether Apophis might change its orbit during that time, is beyond our knowledge until then. Since our astronomical observations were thus blinded, we'd decided to examine the risk of deflection in the course of a model simulation and to find out what kind of push it needed to put Apophis on a dangerous course. When does Apophis become a threat? First of all, it was necessary to determine how large the corresponding deflecting asteroid would have to be in order to influence Apophis to a dangerous extent during its time that it's invisible to us. Previous investigations had already shown that the asteroid's trajectory would have to be shifted laterally by about 200 kilometers in order for it to enter the next keyhole. This, in turn, refers to the small zone in the vicinity of the Earth in which the Earth's gravitational pull would deflect the asteroid in 2029 to such an extent that it would change its course to head for the planet during its next flyby in 2036. In this regard, Weird came to the equally sobering and astonishing conclusion that even a collision with an object just 60 centimeters across would be enough to nudge Apophis through the keyhole. Expressed in numbers, the collision would change the asteroid's speed by about 3,000 ths of a meter per second, thus paving the way for the required 200-kilometer shift in its orbit. In the event that Apophis hits us as early as 2029, however, a significantly greater momentum would be required. To be more precise, the asteroid's flight speed would have to change by about 0.05 of a meter per second. Or, in other words, it would have to collide with a 3.4-meter-tall object. And yet, the mere impact would not be enough. According to Weird, it would also have to occur at a very specific time and direction. But how likely is such a scenario? Well, in principle, about 140 objects of 60 centimeters in size hit the Earth every year, and on average, only one object of 3.4 meters in diameter. But since Apophis's cross-section is considerably smaller, the impact rate is reduced accordingly. The bottom line is that the probability of the asteroid getting into the keyhole as a result of a hit is just 1 in a million. The risk of a collision in 2029 is even lower. Weird puts the probability of Apophis being hit by a 3.4-meter-wide asteroid at just 1 in 100 million. Considering that only 5% of such hits are associated with a decisive impulse, the probability for this case is even less than 1 in 2 billion. Consequently, the risk of impact can confidently be described as very low. But unfortunately, very low does not equal zero. As things stand, we cannot completely rule out an impact. And if chance does ultimately strike, all our mathematical predictions will no longer be of much use to us.